What we see here is Complex 17, the booster being rolled out to the site, and this happened back on April 15th of 2009. As you can see in the video, the crane hook is attached to the forward end of the vehicle and is lifted out of its carrier. One thing to note is that the actual tower rolls forward and the booster is lifted up from its horizontal position to a vertical, and it swivels on the hinge points here on the back end of the booster. Now the booster itself will contain today the RP1 and liquid oxygen tank, and it feeds the Pratt & Whitney Rocketdyne RS 27-inch main engines during the ascent. This first stage will provide about 237,000 pounds of thrust and will burn for approximately about 263 seconds through the flight. As you can see on the side of the vehicle, you see some numbers identified, and that's the location where the solid rocket motors will be attached to, which we're going to see here in a few minutes. And the technicians and mechanics take great care at positioning the vehicle into the tower, and with the bridge crane before it's hoisted up a little bit more to clear any objects it has before the actual tower will roll over the pedestal to bring the vehicle in place to the launch site. As you can see off to the right hand side here is the umbilical tower, which will provide the servicing to the vehicle on the first stage and second stage as well. That's a good look right there of the flame duct, where it deflects the flames at liftoff so it doesn't bounce back onto the vehicle and damage it anyway. What we have here is the GEMs, the graphite epoxy motors, solid motors called GEM 40s, being lifted up out of their cradles, and they do this one at a time. There's a total of 9 solids for this mission, and the first 3 sets will get lifted on one day, and then 3 on the next consecutive 2 days. The GEM motors weigh about 13,000 kilograms each, and they burn for about 64 seconds during the flight. And they each put out about 110,000 pounds of force at liftoff. As I said, they're GEM 40, which means they're 40-inch diameter, and they have a length of about 12.6 meters or 42 feet in length. There are basically 2 types of GEMs that will be on the vehicle today. There is the 6 ground-lit solids, and then there's 3 air-lit solids. And what this means is that T0, 6 of the motors will ignite and provide thrust to help the vehicle up, and then these 3 will burn out and separate from the vehicle, while the 3 air-lit will continue for the next 64 seconds. You can see in this picture here, the solids are going up inside the tower. They bring the tower out. They put the GEMs inside the tower. Then they will roll the tower forward around the vehicle itself. Now, the reason we have 2 different types is the atmospheric pressure on the ground is a lot denser, and we have a different nozzle configuration on the ground lits as compared to the air-lit solids, where we have a much larger nozzle to have a better expansion ratio to get better performance at the higher altitudes. The GEMs are manufactured at their ATK, and they will be used. Actually, the vehicle has different configurations. There's a 3 solid, a 6 solid, 4 solid, and a 9 solid configuration. We'll be using a 9. Now, just to go back in history a little bit on the Complex 3017B, this pad was developed back in 1956 for the Thor program, and this was when the first operational ballistic missile was from the U.S. Arsenal was developed. Complex 17's first flight was back on 25 January 1957, which is about 52 years ago. They've been flying vehicles from this pad. Since then, since 1957, there's been major modifications to the pad to accommodate the different variations of the launch vehicle themselves. And today we have the Delta II vehicle, which has been the fleet flown out of Complex 17 at this time. Now, the pad is currently run by the U.S. Air Force, and there's been over 300 vehicles, Delta vehicles flown to date. The Delta vehicle, when it's fully stacked with the second stage, is 126 feet tall and 8 feet in diameter. And this morning, STS demo will be riding on Delta vehicle 344. Here you see the vehicle with the 9 solids attached to it. Right here you got the tower rollback, which happened about 10 p.m. this morning, and the crews came out bright and early and rolled back the vehicle with the encapsulation. One thing we didn't see was the second stage being erected onto the vehicle, and that was back on May 5th. The second stage was erected onto the vehicle, and to help the performance on the latter phases of the ascent and flight. The spacecraft itself was erected back on August 27th of 2009, and the spacecraft weighs approximately 5,000 pounds. And as you see on the upper end, that the spacecraft is actually enclosed by the 3-meter, 10-foot diameter composite fairing, and that was put down around the vehicle on September 9th. And here we have it, a memory of a fellow friend and colleague that worked the STSS program, Dirk, who passed away about a week or so ago. And here's the vehicle standing tall and ready to go. And you can see the attachments from the umbilical tower up into the payload fairing, providing humidity and air control. This is also, you can see the different sizes of the nozzles here. I was talking about earlier about the different sizes on the airlet and the ground solids. And once again, we see the vehicle from the side, showing the umbilical tower along with the vehicle attached. This is a close-up of the emblem on the side. You see the Missile Defense Agency insignia, the NASA insignia, the ULA, and the actual Delta insignia with the United States flag sitting there with it. Along with that, we're awaiting the team to continue looking at the weather and to see how it's going to progress into our launch window. So.
Well, thank you, Garrett. Can you tell me what were some of the challenges in preparing the vehicle for flight?
Well, you know, every vehicle has its own personality. Every spacecraft has their own personality, and this was just the same. They had some challenges that we had to work through our integration process. Being as the Missile Defense Agency, another government agency, they have ways they do business. We have ways we do business, and we work together very well and synergized on getting to this day.
Well, that's wonderful. Is there anything particular about the Delta II vehicle that makes this the right vehicle for this demo mission?
Well, the Delta II has been a workhorse for the government, and the mass we talked about was 5,000 pounds, fits right into the Delta II performance class very well, which made this a very good match. You don't have very much waste on your performance, or you don't, so it's fits very well.
Well, thanks, Garrett. We appreciate you taking the time to stop by this morning, and good luck to you and the team, and we look forward to a great launch today.
Thank you. It was my pleasure.
At T-minus 1 hour, 23 minutes and counting, this is Delta Launch Control.